So we're going to solve a problem quickly. Jam past question. Let's solve a problem now. Now let's solve this jam question. Okay, under sound waves. We want to put the formula above into use. So given that Young's modulus for aluminium is 7.0 times 10 raised by 10 Newton per meter squared, and density is 2.7 times 10 raised by 3 kilogram per meter cube. Find the speed of the sound produced if a solid bar is struck at one end, okay, with a hammer. So this is how the jam question looks. So we're going to solve that now. Solution. Let's extract the data. Given that Young's modulus, so our Young modulus E is equal to, our Young modulus E is equal to 7.0. So let's write it out. 7.0 times 10 raised by 10 Newton per meter squared. Then our density is given to be, so let's represent that density, okay, density is equal to 2.7 times 10 raised by 3 kilogram per meter cube. Now we're asked to find the speed, so we're going to do that. We'll do justice to that. So find the speed. V is equal to unknown. What formula are we going to use here? The formula that we've proven above. So we're going to use that formula now, so that we know that V is equal to, using V is equal to square root of Young modulus over density. We now have V by substitution is equal to square root, let's draw it this way, square root of 7.0 times 10 raised by 10, all divided by 2.7 times 10 raised by 3. Now if you do this, you see that V is equal to, okay, our calculator will give you V is equal to 5091.75. So if you write this in standard form, you have V is equal to 5.1 times 10 raised to the power 3 meters per second. So this is the solution to this problem. I hope you've learned one or two. This question is jam question under sound waves using Young modulus. Connect to our social media handles at PhysicsBible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.